Hello everyone. So today we are discussing about the double integration. So the double integration. Let's see. This is x-axis and this is the y-axis. Okay, and this is the one rectangle. Okay, so we need to find that area of this rectangle. Okay, so we need to find the area of this rectangle. So I divide this rectangle into n equal parts. So here the listen the one more concept n in n parts in equal parts I am dividing. So this is that. So this is n equal parts I am dividing. Now, so let us take this part. Let's take this part. So this is also one rectangle, no? So we know that uh, the area of rectangle, the area of the rectangle. So the area of the rectangle, we know that L into B. Okay. So this is the one part is there, no? So now this is the X, no? So let's take this is 0, X1, X2, and X3, X4. Okay. Now this is a Y value corresponding. So this is Y1, Y2. So then let's take this Y3 and let's take this is Y4. So what is the length here? X3 minus X4. So X3 minus X4. So that is nothing to what is that? Dx. You know, next Y3 minus Y4. That is nothing to dy. Okay. So that L equal to dx. So this is nothing to what is that? L. And this is nothing to what is that? V. So that's become dx into dy. Okay. So this is the only one part area of triangle. But we need the complete area of the triangle, no? So, so the complete area of the triangle. That means we have to do summation. So summation I equal to 1 to n. That's f of x comma y dx dy. Okay, so I equal 1 to n f of x comma y dx dy. But we need complete, no? So summation. So before that, integration. So I will tell that integration. So integration is nothing to what is that? Summation. Integration is nothing to what is that? Summation or adding. Okay. Now derivation. So what is the meaning of the derivation? Derivation is nothing to splitting, integration nothing to adding. Okay, so in integration symbol we are using this one, this symbol, no? So why we are using this symbol means integration is nothing to what is that? Summation. Okay, so what is the first letter? This is yes. So that S, no. So just that we extend, that is the same. Okay. So the summation is nothing to what is that? Integration, no. So from there, so this equation we can write as the double integration of f of x comma y dx dy. Okay, the double integration of the f of x comma y dx dy. Okay, so this is that we are using the double integration symbol. Okay, and now let's we go to the problems. Now let's see, this is the evaluation of the double integration. So the double integration of A to B, these are the x limits. So these are the y limits. So f of x comma y dy dx is nothing to A to B, and integration of y1 of x, y2 of x, f of x comma dy dx. See, one more thing you have to understand, the integration with the square brackets evaluated by first by integrating that partially with respect to y treating as x constant. So listen one thing. So when you're doing the integration with y, okay, so x is a constant. Okay. So when you're doing the integration with x, then y is a constant. Okay. So this is the things. So x is a constant and y is a constant. This when you're doing the y, x is a constant, and when you're doing the x, y is a constant. Okay. So this is the important concept. This okay. Yeah. So let's see the one problem is there. So here the important thing. So when you are doing the integration with y, x we are taking as a constant. So when you are doing the integration with x, then we have to take y as a constant. So now see here, the double integration of 0 to 2 and 0 to x and y dy dx. Yes, no? So y dy dx. So here, how do we know that are the x limits and that are the y limits means? See the y limits, they are giving in terms of x. Remember one thing. X limits are in terms of y. So here there is one numerical limits are there, one variables limits are there. So let's see the variable limits 0 to x. So this is x, x variables is there, no? So it should be y limits. So it is y limit, then automatically the remaining part is what is that? 0 to 2. So 0 to 2 is automatically that are the x limits. Understood? So 0 to 2 and 0 to x, y dy dx. So that equal to, first we are already they given dy dx, no? Otherwise, if the same question, if they are giving 0 to 2, okay, 0 to 2 and 0 to x, y dx dy. So y dx dy, no? So y dx dy. So here, the way first let's see the variables, limits. So these are the limits in variables, no? So these limits are, we know that it is the y limits. So if there are y limits will be there, variables. So first we have to do that integration with y. So first we are doing the integration with y. So y dy. So y dy is nothing to what is it? That is y squared by 2. So y squared by 2 and the limits are 0 to x. So 0 to x, that is become y squared by 2. And when apply the limits, first to x, in place of y we have to substitute x, that is become x squared by 2. And again in place of y we have to substitute 0. So that is x squared by 2 minus 0 by 2, that is become x squared by 2. So 1 by 2 right outside and x square into dx. So x square into dx integration is x cube by 3. So x cube by 3 and 0 to 2, that is become 8 by 6. 8 by 6 equal to 4 by 3. Okay. Now this is that important problem. Now you got it, no? So first we are doing the integration with y. So y dy. So that is y squared by 2. And next we are applying the limits of y. So after that we are doing the integration with x. And again we are applying the limits of the x. So this is 8 by 6. 8 by 6 equal to 4 by 3. Now let's see here. One more problem is there. Okay. So now evaluate 0 to 3, 0 2 to 3, 2 to 4 x square y cube into dx dy. So let's see here, observe here. Okay. So 2 to 3 and 2 to 4. Which are the x limits and which are the y limits means? Now first we here observe this term. Dx dy, no? So when you are doing the dx dy, so the x limits are become this one. And the y limits are here. Understood? So these are the x limits and these are the y limits. Okay. If they are not mentioned that x limits are y limits. So here first they given with the dx, no? So we can do the integration with dx or we can do the integration with dy. So first here is did integration with dy and x square outside. So x square dx is outside and y cube. So y cube integration is y power of 4 by 4 and 2 to 4 dx. So this is 4 power of 4 minus 2 power of 4 and 2 to 3 x square into dx. Okay. So this is, and we can apply the limits. Here 2 power of 4, that is 256 minus 2 power of 416. Okay. So minus that we are getting and by 1 by 4. So we are getting 16. So next and this part. So this part is x square into dx, no? So x square into dx, that has become x cube by 3, and the limits are 2 to 3. So after the simplification, and we are getting what is it? P8t. Okay. And this is important problem. Now you got it now for these two problems. For these two problems, you got it, these things. Okay. Next. Evaluate y into dx dy where r is a region bounded by y-axis and y equal x square and x plus y equal to 2 in the first coordinate. So suppose this is no. So this is first coordinate, this is second, and this is the third, and this is the fourth. So in the first coordinate, no? So first coordinate. So, but we didn't mention what are the x limits and what are the y limits. Okay. So here observe one thing. So we draw the graph. So this is y equal to x square, and next x plus y equal to this one. And here what is that y axis? So y axis is nothing to what is that? X equal to 0 and this one. So this we need to find that. So y equal x square, no? So x plus y plus x plus y equal to 2. So x plus what is the y? So y equal to x square equal. Okay. So from there we can get x square plus x minus 2 equal to 0. Okay. Now apply that factorizations and we are getting that values. Now see this. So here we got the two values. What is that? X equal to minus 2 and x equal to 1. So x equal to minus 2. So x equal to minus 2, x equal to 1. But they are mentioned that are in the first coordinate. So in the first coordinate, x or y are positive, no? So we are not taking to this value. So we are taking x equal to 1. So x equal to 1, then y equal to 1. So here we got it 1. X equal to 1 and y equal to 1. Next, x equal to 0. They are given y-axis, no? So y-axis means x equal to 0. So x equal 0, then x plus y equal to 2 now. So from there we are getting 0 and y equal to 2. And y equal to 2. Then y equal to 2. So this is okay. Now see the x limits where is changing from 0 to x, 0 to 1. Now come to the y limits. So there's already they are giving what is that y equal to x square and x plus y equal to 2. So here y equal we can write what is that x minus 2. So x plus y equal to 2 and y equal to x minus 2. So from there y equal we can write what is that 2 minus x, sorry. So y equal we can write what is it x plus y equal to 2. So y equal we can write 2 minus x. And one more is y equal to x square. But how we can find out these are the x limits and these are that y limits and which are the lower limit and which are the upper limit. So when we draw the line, if we need the y limits, we have to draw the parallel to the y-axis. So first it is meeting where what is that y equal to x square. And where it is exit, that x plus y equal to 2. So therefore, these are the lower limit and that is the upper limit. So polar form. So what is the polar form means? So here, this is the circle equation. No? For the circle, x equal to r cos theta and y equal to r sin theta is the polar form. So in the same way, here we have to polar form. If they are giving the curve in the polar form, there are Cartesian form will be there and polar form will be there. So if they are giving in the polar form, so how we can do the double integration, evaluate the double integration. So that is here. Okay. So r dr d theta. So first we are doing the integration with the r. So r dr d theta and r dr integration of r dr, that is r square by 2, and apply the limit 0 to a sin theta. So after substituting in place of our a sin theta, that is become a square sin square theta. Okay, so a square by 2 right outside, and apply the limit 0 to pi sin square d theta. Sin square theta, that we can write 1 minus cos 2 theta by 2. So 1 minus cos 2 theta by 2 means, and that now we have to do the integration with theta. So 1 by 2 right outside, that is become 4. 1 d theta is theta, and cos 2 theta integration is sin 2 theta by 2. Now apply the limits 0 to pi. Okay. Now in place of theta, we have to substitute pi. Sin 2 pi, sin 2 pi, sin 180, sin 360, that is 0. So 0 by 2. So that's we are getting what is that? Pi a square by 4. Okay. Next to 5.3.2. Oh, one more example will be there. So here also is there. So first we have to do r square dr, that is become r cube by 3. So r cube by 3, that is a, and a into 1 minus cos theta, and a cube by 3 minus a cube into 1 minus cos theta whole cube. So let's take a cube is common, we have to take outside. So next to 1 minus cos theta whole cube. A minus b whole cube formula. What is that? A minus b whole cube. A cube minus b cube plus 3a square b minus 3a square b. Now if you are substituting here. Okay. Now 1 get cancelled, and we are getting 3 cos theta minus 3 cos square theta plus cos cube theta. 3 cos theta. So 3 cos theta integration sin theta, and cos square theta integration. We have that binomial formulas will be there. That's we are using 1 by 2 into pi by 2 m by n minus n. And cos cube theta also we are to using that integration formulas. From in your test in the Google also you can get it. Otherwise in that intermediate level we have these formulas. Okay, so after that, and we are getting that value a cube by 36, 44 by 44 minus 9 pi. Okay, so this is now evaluate the integral using the polar form, using the transformation into polar coordinates. So this is x comma y variables is there, and we have to change it r comma theta. Okay, so when you are x comma dx dy, so when you are changing that dx dy, so when you are changing to the dx dy, so that's we can write r dr d theta, r dr d theta. So dx dy is become r dr d theta. Okay. So dx dy equal to r dr d theta. Now we know that when you are coming to the circle, so suppose x square plus y square equal to a square, you know. So x square plus y square equal to a square. So what about this radius is become a. Okay. So in the same way, the radius is become r equal to 0 to a. So then the theta is, so when it is theta is, that is become 0 to pi by 2. Okay, so the theta limits are 0 to pi by 2 and the radius is r equal 0 to a. And we know that y equal to r sine theta and x equal to r cos theta. So these are the polar coordinates for the circle. So we know that in the previous studies. So these are the polar coordinates for this study. So y equal to r into sine theta and x square plus y square equal to r, and dx dy equal to r into dr d theta. So that is become r cube sine theta dr d theta. So r integration is r power of 4 by 4. Okay, and sine theta integration is, that is minus cos theta. Or dr d theta. So r cube sine theta dr d theta. So r cube d theta integration, r cube dr is then r power of 4 by 4. So and sine theta integration is minus sine theta. So when you're doing the r integration and we have to apply the limit 0 to a and sine theta d theta, sine theta integration is cos theta. So after that, and we are getting. So there is a one verify your answer. So no, by general method. So this is also is the same. Okay. Next, change of order of integration. Previous is what is the change of the variables. Now here change of order of the integrations. So orders we have to change it. Okay. So this is the task. So here how we can change the limits. Suppose x limits they are giving and y limits they are giving. So x limits and y limits we have to change it. Okay. Then we have to evaluate. Okay. Let's see here one problem. Here the y limits 0 to under root of 1 minus x square. So how you know find out that is the y limits means, okay, that under root of 1 minus x square. So the limits are in terms of x, no? So automatically it should be y limits. So y equal to 0 and y equal to under root of 1 minus x square. Okay. So 1 minus x square. So that is x square plus y square equal to 1, and that is a circle. So in the changing the order, then we are getting x equal 0 and x equal to under root of 1 minus y square. So in the slide between y equal to 0 to y equal to 1. See, so previous y equal to under root of 1 minus x square. No? So now that we are getting y square equal to 1 minus x square. So from here, x square equal to 1 minus y square. Then x equal to under root of 1 minus y square. So this we are getting. Okay. So observe here. So previous, these are the y limits are what is it? 0 to under root of 1 minus x square, and x limits are 0 to 1. Now that is changing to the y x limits are 0 to 1 minus x square and the y limits are 0 to 1. So first 1 into dx. So 1 into dx is nothing to x, that is 0 to under root of 1 minus y square. So in place of x, we have to substitute under root of 1 minus y square and y square into under root of 1 minus x square. See, this is going to very lengthy procedure using the UV formula in the integration. So for the simplification, and we are getting that put y equal to sine theta, then dy equal to become cos theta d theta, and theta is varies from 0 to pi. Now, if you are substituting that y equal to sine theta, so y equal to sine theta, that is become sine square theta, and this is become under root of 1 minus sine square theta equal to cos theta. And again dy is become cos theta d theta, that is become cos square theta. And this is also integration formulas. So then we are using this is the formula. So this is that. And next, see the next problem. Integration of 0 to 1 and 1 to 2 minus x, xy dx dy. So here the 2x 2y is here 2 minus x. So 2 minus x equal to, that is automatically y limit. So y limits are 1 to 2 minus x, sorry, 0 to x, and x limits are 0 to 1. So it's simplified, then we are changing the order of the equations. So here y equal to 2 minus x now, then x equal to 2 minus 1. Now we shall change the order of the integration. So this is, so the x limits are become 2 minus y and the y limits are is become 1 to 2. So xy dx dy. So first we are doing the integration with x dx. So that is become x into dx, that is become x squared by 2. And now apply the limits. What are the 2 minus y and x equal 0? That is become 2 minus y whole square by 2. Okay, then y into dy. So a minus b whole square, a square minus b square plus 2ab. Then we are getting that. Again, after that, finally we have to do the integration with y. So that is 4y dy, that is become 4y square by 2 minus 4y cube by 3, and y cube integration is y power of 4, and the limits are 1 to 2. So this is 1 by 2 and 8 minus 32 by 3 plus 4. After substituting that 2 is the limit, minus 2 minus 4 by 3 plus 1 by 4. And finally we are getting what is that? 5 by 24. So this is, and similarly the previous problem also. And this is the example problems. Okay. So these are the example. Let's see here. One see that thing. So this is okay. So these all are exercise problems. Let's see, this one is also very simple problem. So this is, so first we have to do the integration with the y. Okay. So after that we have to do integration with respect to x and um, and apply the limits. These are and solve these problems. No? Sir, so these are the important. This is polar form problem. Okay. So in the next class, we'll discuss one more topic.